Realize the given transfer function in direct form 1 and direct form 2. The transfer function h of s is equal to s square plus 3s by 2 plus 2 divided by s square plus 2s plus 2. Solution. Given the h of s we can write like y of s divided by x of s, that is equal to s square plus 3s plus 2 divided by s square plus 2s plus 2. Okay, in the numerator, take s square outside, then 1 plus 3 by s plus 2 by s square. In the same manner, even in the denominator also, we have to take s square outside. So this is 1 plus 2 by s plus 2 by s square. Okay, again now s square cancel. So finally we are getting h of s is equal to y of s divided by x of s, which is equal to 1 plus 3 by s plus 2 by s square divided by 1 plus 2 by s plus 2 by s square. Okay, now this y of s and x of s we have to cross multiply. Okay, once again, now we can remove this h of s. If you cross multiply y of s with this and x of s with this, we'll be getting s is. Okay, so now once we cross multiply, we'll be getting y of s plus 2 by s, y of s plus 2 by s square, y of s is equal to x of s plus 3 by s x of s plus 2 by s square x of s. Okay, this entire equation we'll call it as w of s. Okay, this entire equation we'll call it as w of s. Okay, so now w of s is equal to this equation and also w of s is equal to this equation. So now with this equation we will write the we'll realize the block diagram in the left hand side. With this format we'll realize in the right hand side, that is the output side. Okay, so now I'll write two equation from this. Okay, one with x of s and ws and another one with y of s and ws. Okay, so now I'm going to write this x of s along with the ws first on the left hand side and this y of s along with the ws on the right hand side on the next page. Okay, then we'll be getting x of s plus 3 by s x of s plus 2 by s square x of s is equal to w s. Okay, again in the same manner we have to write y of s with the w of s. Okay, now y of s 2 by s ys plus 2 by s square ys is equal to ws. Okay, anyway, if you remember, we will be starting with x of s, then in the middle we will be getting w of s, again in the end we will be getting y of s. That means what? The first equation we have to try to get w of s from x of s. Okay, but in the second equation we have to try to get y of s from w of s. Okay, so anyway this equation is okay, but this we have to modify because we have to get y of s from w of s. So that means we need y of s from w of s as well as with the feedback from y of s. Okay, so now y of s is equal to w of s minus 2 by s y of s minus 2 by s square y of s. Okay, now we'll start with x of s. Okay, and it's going like this. Then 3 by s into x of s. Okay, so now we'll use one integrator here, 1 by s. Again another integrator here, 1 by s. But with this 1 by s we have to introduce 3. So this branch with the gain 3. Okay, this is summation. Again the second one with the gain 2. 2 again it goes now here. Okay, and then this x of s directly coming, okay, with the 1, Again, one more summation here. It produces W of S. It produces W of S. Okay, now we have W of S. From this, with help of W of S as well as with help of Y of S, we have to get again Y of S. Say for example, in the output side, we are having Y of S. Okay, Y of S. Then Y of S, and we will have one integrator here and another integrator here. Okay, what is the gain here for the first integrator, that is -2. So now gain here is -2. For this one is also gain is -2. So this also -2. Okay, now again we got these two terms. Again WS is coming, that we have to add directly here. Okay, then it goes as Y of S. Okay. So now finally we have realized direct form one structure. Okay, so now we are realizing direct form one structure. This is direct form one structure we are realizing. Okay, direct form one structure, and we know that for direct form one structure implementation, there will be separate integrator for input side and also a separate integrator for output side. W is the temporary middle variable. Okay, we'll be using. And what is the another observation? Okay, what is the another observation? Again, what would be this coefficient? Okay, if you see here in the numerator we are having 3 as well as 2, the denominator 2 under 2. The direct form 1, so from this structure, again, we'll be using this coefficient at the input side without any sign change, but this coefficient at the output side with the sign change. So 3 and 2 at the input side without any sign change. Okay, so 3 is here, 2 is here without any sign change, directly we are using. And then this 2 and 2 sign change we are applying, that means -2 we'll be using in this structure. Okay, this is some simple way. With this you can easily verify. Again, there will not be any sign change for this one. Okay, so here also 1 only, here also it is 1, there will not be any sign change there. Okay. Then same thing we have to realize with the help of direct form 2 structure. Same question, direct form 2 structure. Okay, so same H of S we are taking, Y of S divided by X of S equal to this expression, and this is writing just to verify the final. Okay, output side we will be using this coefficient without any sign change. Input side we will be using with sign change. And also we know that direct form 2 means we will be using common integrator for both input and output. Okay, now this Y of S divided by X of S can be modified like this: Y of S divided by WS divided by X of S. Okay, so I am introducing WS, okay, both numerator as well as in the denominator, so that again I will be getting Y of S divided by X of S. So then this is 1 plus 3 by S, 2 by S square, 1 plus 2 by S, 2 by S square. Okay, then this first term I can separate. Y of S divided by W of S means 1 plus 3 by S, 2 by S square. Then W of S divided by X of S means 1 by 1 plus 2 by S plus 2 by S square. Okay, so now what we need from this equation, okay, with this equation we will realize output side. With this equation we'll be realizing input side. Okay, so actually what we need, X of S will be there in the middle, H of S will be there from W of S will be there. From W of S we'll be getting Y of S. Okay, anyway, the integrator is going to be in the middle. So to get Y of S, W of S from X of Z, how we have to modify this equation, whether we can directly take with the W of S or what we need. See, if you cross multiply this, we'll be getting W of S, W of S plus 2 by S, W of S plus 2 by S square W of s, sorry, finally this is x of s. Okay, x of s. But what we need W of s, so that we'll be modifying this. W of s is equal to x of s minus 2 by s square W of s. Okay, I think there is no proper space. Okay, we'll write it on the next page. So W of s plus 2 by s W of s 2 by s square W of s is equal to x of s. But what we need W of s. Okay, we will keep W of s alone this side, remaining term we will take other side. Okay, then with respect to this, what we need finally y of s. So directly we can get that from here. Y of s is equal to W of s plus 3 by s W of s plus 2 by s square W of s. Okay, now we will write this equation on the next page, but we need W of s alone. Okay, so remaining term, take that side. Okay, so W of s is equal to x of s. Okay, because x of s is already there, then this two term with minus sign. Okay, minus 2 by s W of s minus 2 by s square W of s. Okay, similarly, this equation directly we can use y of s. Y of s is equal to ws plus 3 by s ws plus 2 by s square ws. Okay, ws 3 by s 2 by s square. Okay, now x of s is there here. Okay, now it's going here, but here we are having common intermediate function, that is ws. Okay, we need ws from x of s as well as from W of s combined together. Okay, so I can use one addition here. Okay, it comes this way. Then use integrator here 1 by s, another integrator here 1 by s. Okay, the first integrator with the sign of minus 2, second integrator with the sign of minus 2. They will be added here. Okay, again, it will be added with the original function x of s. Okay, so now x of s is coming, and also ws multiplied with 1 by s multiplied with minus 2 is also coming. And then similarly ws multiplied with 1 by s square, because you are coming this way 1 by s square, and also this minus 2 is this minus 2, and then again you are adding that also. So finally you will be getting w of s. Okay, from this again we'll be introducing the we will try to get y of s from w of s. Okay, so for the already w of s is there. Okay, again we need 3 by s. Okay, already 1 by s is there, so you introduce 3 here, branch gain 3. Okay, then one adder, and again here you will be getting 1 by s square, but with the branch gain 2. Okay, then you take this way, you add with this. Okay, then finally you will be getting y of s. Okay, you'll be getting y of s. Okay, so this is the direct form to realization. Direct form to realization. That means what, we are using only two integrator. Okay, that is common to both input as well as the output. Okay, and also we will verify that shortcut. What is that shortcut? The output side, we have to use this variable at the output side without any sign change. That means 3 under 2. 3 under 2. Again, we have to use this variable 2 under 2 on the input side with the sign change. That means minus 2 minus 2. Okay, now we are using. So same thing you try with the Mason-Gaines formula. Anyway, that is not may not be relevant to the signal system, but you will get some intuitive idea how the Mason's-Gain formula is also working in signal system. So you take it as an exercise. Okay, you try to apply the Mason's gain formula for this one, then ultimately you get h of s. Okay, your original h of s. Okay, again here also you can apply the Mason's gain formula and verify whether finally you are getting h of s is of this format. Okay, next question. Okay, so realize the following in the direct form 1 and direct form 2. Now the transfer function is not given directly, it's given indirectly with the help of the differential equation. Okay, so take the Laplace transform for this differential equation. S cube ys 4s square ys plus 7s ys plus 8 ys is equal to 5s square xs plus 4s xs plus 7xs. Okay, now take y of s separately. S cube plus 4s square plus 7s plus 7s plus 8. Here take x of s separately. S square 5s square plus 4s plus 7. Again bring that x of s this side. Okay, so y of s divided by x of s is equal to 5s square plus 4s plus 7, then s cube plus 4s square plus 7s plus 8. Okay, now the problem here is the numerator is having degree 2, but the denominator is having degree of 3. Okay, so now the numerator is having the degree order of 2, but the denominator is having order 3. So take s square from here, we'll be getting 5 plus 4 by s plus 7. Here, if we take s cube outside, we'll be getting 1 plus 4 by s, 7 by s square plus 8 by s cube. Okay, so now if you see s square by s cube, then we are getting 1 by s. Here we are getting 1 by s. Then 5 plus 4 by s plus 7. Okay, then 4 by s plus 7 by s square plus 8 by s cube. So what we can do, this s we can take it in the, again here we made a mistake, this is s square. Okay, 7 basis. Okay, so now what we can do, we can take this s side, sorry, we can take this s in the numerator, we can absorb here in this equation. So we'll be getting 5 by s plus 4 by s square by 7 by s cube, and this one is 1 plus 4 by s 7 by s square plus 8 by s cube. Okay, now what is the difference? We are not having this one term here in the numerator, so in those places we will put 0. Okay, see, previously we got some one value like that, here we will put 0, this branch value as 0, that's it. Okay, so this instead of 1 here 0 is there, so that branch we will remove. Okay, then rest of the things remains same. Okay, so then first direct form 1 realization. So this is y of s divided by x of s. Now this x of s we can multiply with this one, that is that we call it as a w of s. Okay, so 5 by s x of s plus 4 by s square x of s plus 7 by s cube x of s. This y of s we can multiply with this. So ys plus 4 by s ys plus 7 by s square ys plus 8 by s cube ys. Okay. Again, we will take ws with x of s separately and ws with y of s separately. Then we'll get both input side structure and output side structure. Okay. So then from this equation, what we need ws in terms of x of s. So that is directly available here. But whereas here we need y of s from ws. So the second equation only will modify. First equation will write as it is. Okay, so what is the first equation? Ws is equal to 5 by s x of s plus 4 by s square x of s 4 by x square x of s plus 7 by s cube x of s. But the second equation, I will try to start with ys. Okay, then this term will come in the negative. Okay, so ys is equal to, anyway, that ws is there already, ws minus 4 by s ys minus 7 by s square ys minus 8 by s cube ys. Okay, now from x of s we have to get w of s. Okay, x of s is coming this way, but directly we are taking integration because no separate x of s term is there here. Okay, if it is there we will put one line here, but it is not there, so directly we take integration 1 by s, then another integration 1 by s, then another integration 1 by s. Okay, first integrator with the coefficient of 5, second integrator with the coefficient of 4, third integrator with the coefficient of 7. Then we will add all. Okay, then now we got w of s. Okay, so this output is w of s. Okay, from w of s, again we need to get finally y of s. Okay, then y of s comes this way, 1 by s, one more 1 by s, and one more 1 by s. Okay, now this is multiplied with the gain of minus 4. This is with the gain of minus 7. This is with the gain of minus 8. Okay, then finally this is added with here. Now it goes here. Okay, so if you see this structure, it is looking a little bit different as compared to the original structure. Okay, if you are not convenient with this, okay, you can put one more branch here, but with the gain of 0. Okay, then again you can put one more adder here. You can take this output here. Again, this tapping, instead of taking this line, you can take this line here. You can bring this line here, and everything you can bring up. Just okay, just by disconnecting this. Okay, you can correct this branch here. Then definitely it will look like your original structure. Okay, anyway, both are same. Okay, because even if there is a branch here, you are putting 0 gain. Then again, the same way how this network is working, in the same way your existing structure also will work, no problem. So just it is looking different, but it is exactly same as the original structure of this format. Okay, okay, you can also realize in this format, no problem. Okay, just try that. Okay, so now we will erase this. Okay, so now this is the direct form 1. Direct form 1. Okay, then direct form 2 realization. Next, direct form 2 realization. Okay, in direct form 2 realization, y of s divided by x of s is equal to y of s divided by ws. Ws divided by x of s is equal to 5 by s plus 4 by s square plus 7 by s cube divided by 1 plus 4 by s 7 by s square plus 8 by s cube. Okay, then y by s w s is equal to 5 by s plus 4 by s square plus 7 by s cube. Then ws divided by xs is equal to 1 by 1 plus 4 by s plus 7 by s square plus 8 by s cube. Okay, now this is y of s with respect to w of s. Okay, this we can directly implement just by writing like this. Y of s is equal to 5 by s ws, 4 by s square ws, then 7 by s cube ws. But this, if you cross multiply, you will be getting x of s with respect to ws. Okay, but we need x of s from ws. Okay, so first of all, first we'll cross multiply this. We will be getting ws plus 4 by s ws, 7 by s square ws, 8 by s cube ws is equal to xs. Okay, but what we need finally is equal to x of s, but we need ws. Okay, so ws is equal to xs minus 4 by s ws minus 7 by s square ws minus 8 by s cube ws. Okay, so ws is equal to x of s is already there. I am taking this term to the right side. Minus 4 by s minus 7 by s square minus 8 by s cube. Okay, so now we can realize from this, we can realize the input side of the network. From this, we can realize the output side of the network. So direct form 2 structure goes like this: x of s okay, again the integrator will be in the middle, that is common to both input and output because it is direct form 2 structure. Okay, now what we are doing here, we are trying to get ws from this. Okay, ws is equal to xs. Okay, ws is equal to xs. xs is added here in this adder. Then that is 1 by s into ws, but with the negative sign. So that's why 1 by s with the negative sign minus 4. Then 1 by s square into minus 7. So s square you are getting again minus 7. Here 1 by s cube into 8 minus 8. Okay, s cube 1 by s cube with the minus 8. So you are adding everything. Finally, you are getting ws. Then in the output side, what is happening? Y of s is equal to 5 by s ws first. Okay, see ws is there here. Sorry, ws is there here. The first y of s is ws multiplied with 1 by s and also along with 5. Okay, so that is 5 by s ws. Then 1 by s square multiplied with 4. Okay, that means 4 by s square. Then 1 by s cube multiplied with 7. Okay, that means 7 by s cube ws. Okay, finally we have realized the direct form 2 structure. Okay, so in the next class we will see how to realize in cascade form and also in a parallel form. Okay, thank you.